Hi PhysCalc, and welcome to another video tutorial. In this video tutorial, we're going to be talking about U-substitution, and in particular, U-substitution with polynomials. Now, we are very familiar with polynomials at this point. We know a lot about how to take their derivatives and integrals, but what we're going to do now is learn about what to do when we want to integrate a polynomial that is inside of another function. For example, we have an entire polynomial being raised to a power. So something is happening to the whole polynomial. And that is when we need to use our beautiful U-substitution. So for this example, let's pick a function. Let's say we want to take the integral of 4x times 2x squared plus 3 to the 7th dx. So maybe I want to take this integral. Well, it looks like I might need U-substitution because I see immediately I have a thing that is embedded inside of an x to the 7th. So that's a pretty good indication that I might need U-substitution. What I need to do now to figure out if it is U-substitution is figure out if I can get it into the form integral f of u du. Because remember, if I can get my function to look like that, then I'm in good shape. And to get into this form, I'm going to need an f of u, and I'm going to need a du. So that's my job now, is to figure out if I can figure out what f of u is and what du is. So first things first, let's figure out if there's something in here related by a derivative. Is there a u thing that I can take the derivative of and get my du thing? And right away, I'm seeing this sort of 2x squared in here, and I'm seeing this 4x over here, because the derivative of 2x squared is 4x. Now, lucky for me, I can actually expand this a little bit, because the derivative of 2x plus 3, the whole thing, is also 4x, right? Because that plus 3 will just become plus 0. So I can take the entire thing inside of my 7, and I can call this whole thing, this whole 2x plus 3, my u. So let's go ahead and do that. If we make u 2x squared plus 3, that means the thing I'm doing to it, the f of u, would be u to the 7th, because the thing I'm doing to my 2x squared plus 3 is taking it to the 7th. All right, so now that I have that, I need to figure out if I can get a du. What is my du equal to? To do that, I need to do d over dx of u, and that is going to give me d over dx. U is equal to 2x squared plus 3, so 2x squared plus 3. Doing that, I find that the derivative of 2x squared plus 3 is equal to 4x, so du dx is equal to 4x. And then, remember, it's not quite multiplication, but we can think of it like that. If I take my dx and I move him over here, then I can say that du is equal to 4x dx. And lucky for me, I have a 4x in my original function and a dx in my original function. So if I rewrite this function as the integral of 2x squared plus 3 to the 7th 4x dx, so I just moved my 4x from one side to the other, I can see really clearly that this whole thing is f of u, and this whole thing is du, because of what I found down here. So all of my puzzle pieces have been located. My du is 4x dx, and I can now go ahead and solve my integral f of u du. Remember, because f of u is u to the 7th, this is equal to the integral of u to the 7th du. Taking the integral of something to the 7th just means that I do 1 over 8 times that thing to the 8th plus c. Last step is just to plug in my u stuff to make it an x again, which I have up here. So I'm just going to use this down here on my u, and I will find that I get 1 over 8 times 2x squared plus 3 to the 8th plus c. And that, y'all, is my answer. And that is how we use U-substitution to find the integral of embedded polynomials. All right, happy U-substitution and good luck, guys.